In the second video of Lesson 2, we will consider another example where we examine the influence of outliers on a set of data, then summarize some of our findings from both videos in this lesson. Let's consider the set of data 66, 25, 72, 64, 111, 68, and 70. In A, we are going to determine the mean, median, and mode for all of the data values. To calculate our mean, add those values, 64, 111, 68, and 70, and we have in this set of data 7 pieces. So we divide by 7. We add the values in our numerator, and we will get 476, divide by 7, and that gives us a mean of 68. Next, we consider the median. Here we organize least to greatest, 25, 64, 66, 68, 70, 72, 111. 7 pieces of data, that's an odd number, so we will have a distinct middle piece. I group the first 3, I group the final 3, leaving me with a median equal to 68. We do notice here that our mean and our median are the same value. For the mode, we need to consider a piece of data that repeats itself. But when we look at our data, there is no data value that repeats. Therefore, no mode exists. B. Does an outlier exist in this data set? When we have a close look at our data values, there are actually 2 that stand out, those being 25 and 111. The 25 is significantly less than the other values, whereas the 111 is significantly greater. So to answer our question, does an outlier exist? Yes, 25 and 111 are outliers. And you know what's coming next. We are going to now calculate the new mean, median, and mode with the outliers excluded. Here we go. Mean, so we add the new set of data without the outliers. We have a 66, a 72, 64, 68, and a 70. Because we have now excluded 2 data values, that leaves us with 5. So we divide by 5. Add those values in the numerator, we get 340. Divide by 5, and our mean, our new mean, is 68. With a quick glance up top, we see that the mean hasn't changed. Median. Let's see what happens to the median here. To calculate our median with the outliers excluded, we first of all list our data values, least to greatest, those that remain, 70 and a 72. We are left with 5 pieces of data, so once again, there is a distinct middle piece. I group the first 2, group the last 2. That leaves me with 68 in the middle. Therefore, the median equals 68. With a quick glance up top, what do we notice? Median hasn't changed. Interesting. And for our mode, there were no data values in common at the beginning, and there will be no data values in common once we have excluded the outliers. No mode exists. As I've already alluded to, when we look at our values here for mean, median, and we compare our values with the outliers included and excluded, we notice that absolutely nothing has changed. Not only is our mean and median the same in both sets of data, even with the outliers excluded, those 2 measures of central tendency did not change in value. Which begs the question, why? What is it about this set of data, and even with the outliers excluded, that it does not impact or influence the measures of central tendency? What I'd like for you to think about before we continue is the fact that 25 is one value that was significantly less than the other values, and 111 is one data value that was significantly greater. In removing them, it's like they balance each other. They cancel each other out in a sense. In summarizing our findings, let's revisit our question from the beginning of this lesson. If our data set has an outlier or outliers, what effect may it have on the measures of central tendency, the mean, the median, and mode? Well, depending on the data set, outliers may or may not influence the measures of central tendency. If we have the same number of outliers that are significantly less or significantly greater, the effect on the mean, median, and mode will likely be minimal if there is any effect whatsoever. Just consider our previous example. This was the original data set. When we excluded our two outliers, 25 and 111, there was no impact on the mean, median, or mode. An exception here would be the unlikely circumstance whereby the mode is actually an extreme value. In this data set, we have two values significantly greater and two values significantly less. But the two significantly less data values would actually give us our mode. So if we remove all outliers, obviously our mode will be impacted, as there would be no mode for the remaining data values. Another finding, an outlier will tend to have the most influence on the mean. If you have multiple outliers on the same extreme, the median will also be affected, but not as much as the mean. If we consider the data set to the right, if we do the calculation for the mean and median for all data values, we will get a mean of approximately 45.1 and a median of 57. That's with the outliers included. And our three outliers here would be the 2, 3, 4. All three are significantly less than the remaining pieces of data. If we exclude them, look at our mean. It increases to 59.1. That's a jump of 14. Our median as well was impacted. It only jumps 3, but there's still an increase. In our next lesson, we will engage in a discussion as to when we should include or exclude our outliers. Stay tuned. For now, I'd like you to proceed to the activities for Lesson 2.